This is the video for section 6.3 notes, slides 26 and 27. All right, so it says solve the differential equation, right? So what does that mean? Well, when I have dy dx, that means I want to find y equals the original equation, right? So first step in solving a differential equation is to separate the variables, right? So I'm going to multiply both sides by y, right? So I get y dy, and then I'm going to multiply by dx. So I have x squared times the square root of x cubed plus 8 dx. All right, so now once the variables are separate, right, you'll see only y's on the left side and only x's on the right side. Now I'm ready to integrate. So I integrate. All right, so now on the left side, the integral of y dy, that would be y squared over 2. And then, of course, plus c, but remember, we're only going to add in c once. All right, so I'll add it in on the right side. All right, now, in order to integrate x squared times the square root of x cubed plus 8, I'm going to need a u substitution, right? So what is u? Well, first of all, I always look at the function inside of a function. So I have the x cubed plus 8 inside of the square root. So x cubed plus 8 sounds like a good u to try. So du is 3x squared dx. All right, so now take a look here. If I have the integral of, now if I have x cubed plus 8 inside of the square root, that's going to be u to the 1/2, right, square root. And then I have x squared dx, right? So now I recognize that I wanted to have a 3 with my x squared dx. So I put a 3 on the inside, which means I need a 1/3 on the outside. All right, so now I bring down the y squared over 2 equals, now I have 1/3 integral of u to the 1/2, and then remember 3x squared dx, that is du. All right, so now once again, y squared over 2 equals 1/3. All right, integral of u to the 1/2. So u to the, remember, add 1 to the power, 3/2, divide by the new power of 3/2, and then of course the plus c. All right, so now if I have u to the 3/2 over 3/2, that's like multiplying by 2/3. So this really becomes 2/9 u to the 3/2, and u is x cubed plus 8 to the 3/2, and then of course plus c. All right, so now the only other thing that I would do would be to solve for, I could solve for y, but I always like to use the initial condition in order to find the value of c first. So y is -4 when x is +1. All right, so I'm going to plug in -4 squared over 2 equals 2/9 times 1 cubed plus 8 to the 3/2 power plus c. So now we're trying to find the value of c. All right, so -4 squared is 16 over 2 is 8 equals 2/9. 1 cubed, 1 plus 8 is 9 to the 3/2 plus c. All right, what does 9 to the 3/2 mean? It means the square root of 9 cubed. So I always do the root first. So I get 3 and then I cube it, right? So 2/9 times and 3 cubed is 27 plus c. 27 and 9 reduce to give us just 3. So this is 8 equals 6 plus c. So subtract 6, so c is equal to 2. So that means, okay, that I go here and I say, okay, now I have that y squared over 2 equals 2/9 x cubed plus 8 to the 3/2 power plus 2. Now, it's important that we understand the different solutions, right? All right, so this first one, okay, is the general solution, right? Because we did not find the specific value of c, and it is implicitly defined. It is not defined as y equals, right? So this solution is general, but implicit. Okay, now I have found specific solution, but it's still implicit. So now ultimately, our goal is to find an explicit solution if possible. All right. And so that means we want to solve for y. So we're going to multiply both sides by 2. All right. So I get y squared equals 4/9 x cubed plus 8 to the 3/2 power plus 4, right? Multiplied by 2. And then I'm going to square root. So y is equal to, now remember, when I square root, I should include a plus or minus. So plus or minus 4/9 x cubed plus 8 to the 3/2 plus 4, right? But now remember, plus or minus, we can't have both, okay, because we're looking for a specific solution, right? So I need to have one of the two. Now, you go back to the original. When x is 1, y is -4. So that means the only way to get y to be a negative is to only use the negative. So y equals negative square root of 4/9 x cubed plus 8 to the 3/2 power plus 4. All right, and so that is my specific and uh, explicit solution to that differential equation. Now, we can't always find a specific and explicit solution, right? So in this case, if I wasn't given that y equals -4 and x equals 1, I couldn't find the specific, right? And if the equation was written in such a way that you can't solve for y, then you wouldn't be able to find the explicit solution. All right, so that's slide 26. All right, what about slide 27? All right, same idea, right? We are given a differential equation, all right, and so we want to separate the variables. So I'm going to multiply by 5y to the fourth dy, and then multiply by dx, so 3x squared minus 2x dx. All right, and so now I see y is on the left, x is on the right, and so now I'm ready to integrate. So the integral of 5y to the fourth dy, so that's going to be 5y to the fifth over 5, right? And then, of course, the plus c, but I could add in the c on only one side. So obviously the 5s will reduce. All right, integral of 3x squared, that's going to be 3x cubed over 3. So, of course, the 3's reduce minus 2x squared over 2. Of course, the 2's reduce. And then don't forget to add the c. All right, so now I have y to the fifth equals x cubed minus x squared plus c. And so now I want to use the fact that y is 2 and x is 0. So 2 to the fifth equals 0 cubed minus 0 squared plus c, right? So 2 to the fifth is 32, and then 0 minus 0 plus c is c. So c is 32. So that means my specific but implicit solution is y to the fifth equals x cubed minus x squared plus 32. And so now, in order to make it an explicit solution, I'm going to take the fifth root of both sides. Now, no plus or minus needed for an odd root. So the fifth root of x cubed minus x squared plus 32. And that would be my specific and explicit solution. All right, so that is